enough with the fossil fuels. Let's talk about alternative energy sources. So what are some types of alternative energy sources? I wish they weren't called alternative. I wish they were called what needs to be mainstream energy sources. This includes nuclear energy resources, which is a non-renewable resource, but renewables like solar, wind, and hydro, which is water-derived energy. So these are all alternative energy sources, sometimes green, referred to as green energy sources. Nuclear is a non-renewable energy source because we're mining out uranium as an energy source to harness that. So there's only so much uranium we can mine out, so it is non-renewable, but it is considered a green energy source. Why is that? Well, let's first focus on nuclear. It's not nuclear. There's not two U's. It's not nuclear. It's nuclear. One of my little things about nuclear energy. So nuclear energy comes from the splitting of atoms of uranium-235. That's a type of uranium. There's different types of uranium-235 referring to the atomic weight. There is different isotopes of uranium. That just happens to be one of them. So what we do with this uranium-235 is that a nuclear power plant uses the heat, all right, the heat generated from nuclear fission to boil water. This water produces steam. Steam spins a turbine, which turns a generator, which generates electricity. I'll explain the fission process here momentarily. Nuclear power plants actually produce almost no carbon emissions, and they can operate 24/7. The only bad part is, well, with the uranium, it's hard to come by. Uranium is only naturally formed in supernovas, when stars explode violently. So how did it get on Earth? Think back to how the planet formed from an interstellar cloud of dust and gas as it was forming. Whatever stuff was in that gas got trapped in all the different planets. We just so happen to have some uranium. So there's not a lot of it to go around. But what is there to go around is very powerful. 1 gram of uranium. 1 gram of uranium. So imagine, a gram being just like the eraser of a pencil. 1 gram of uranium produces 2 million times more energy than 1 gram of coal. So the energy we can get from just this little eraser-sized bit of uranium compared to that same bit of coal, 2 million more times energy locked in there. So how do we harness that energy? Well, it's the process of fission. So on the periodic table of elements, little chemistry, there are things that are radioactive. There are elements that are radioactive. What that means is that they give off stuff naturally. They kind of break down naturally. They give off particles. So we're harnessing the ability of elements to spontaneously break down. So fission is a nuclear reaction in which we take a uranium atom, all right, and we shoot a neutron at it. All right, we shoot just a single neutron at it. Because it becomes unstable, it will naturally start to decay and break down. So when that happens, the atom splits. The atom of uranium splits. It creates some waste material, but in that process, it creates 3 neutrons. So energy is released. That's in a form of heat, so that's where the heat's coming from. There's some waste created, but then also additional neutrons, which then hit 3 other uranium atoms, causing them to be unstable, causing them to split, releasing energy, but also waste, and 3 more neutrons. So 1 neutron can split 1 atom, which creates 3 neutrons, which splits 3, and then those 3 create 3 more, so 1, 3, 9. There's this chain effect. There's this chain effect, this exponential effect during nuclear fission. So again, we shoot a neutron at 1 uranium atom, causing it to become unstable. It's more radioactive, so it wants to split apart. And when it does, it releases material to split other atoms. But another thing that's released is energy in the form of heat. So that's why radioactive things tend to be hot, because they're giving off energy in the form of heat as they naturally decay. So what do? We harness that heat. So we have uranium in a reactor, all right, and it's naturally giving off heat. We shoot a neutron at it, and then it starts this chain reaction of nuclear fission. So energy, heat is being released. That heat heats up water. So there's pipes that go through the reactor that heats up water. Though that hot water is piped into another big pool of water, heating up that water, turning it to steam. Steam flows through pipes, spins a turbine. The turbine spins a generator, which generates electricity. In essence, all electricity, you need to spin a turbine, essentially, spin a generator to generate electricity. That's how it works. Now, to control that process of radioactivity and radioactive fission, sometimes control rods are used to kind of put in to slow down the reaction. If there was no control rods, then all the uranium in the reactor would just, the fission would go on and go on and go on until all the material is fissioned, and that means more and more in energy, more and more heat released. More heat would melt the reactor, and you would have a meltdown when you can't control the reaction. Think of Chernobyl. So we sometimes, well, not sometimes, they have to input control rods, usually made of lead, to help slow that down. It kind of puts the brakes. That lead kind of absorbs some of that fission material to slow down the reaction. So we lower these control rods, put them in or pull them out, depending on if we want the reaction to slow down or speed up. Depending on how much heat we want to generate to create steam, steam to spin a turbine, turbine to spin a generator to generate electricity. So that's how nuclear power plants work. Again, there's usually some sort of containment building. That's where the heat is being generated from the fission process. The steam spins a turbine, which is connected to a generator. Generator generates electricity. The water usually goes to cooling towers. So if you see a nuclear power plant, like on The Simpsons, right, you see this big cooling tower. That's not where the nuclear material is. That's where they send just the hot water to cool down. That water is then recycled back into the system. Some of that water is lost as water vapor, as steam. So actually, nuclear power plants also need a decent amount of water. So, you know, while they're relatively clean, unless a major issue happens, it also does require a lot of water. This is the Palo Verde nuclear generating plant. This is about 30 some miles kind of west of us here in Phoenix. So kind of out past Tonopah. Maybe if you looked out to the west on a cold morning, you see steam rising. That's the Palo Verde nuclear generating power plant. This is the second largest electricity generating power plant in the country, right here in Phoenix. It's great, you know, it's green. There's no emission. This is just water vapor. This is just hot water. There's no CO2 emissions. It's great, but, it is nuclear. So that waste has to go somewhere. But anyway, this is a very large plant, the Palo Verde nuclear power plant, the second largest as far as output of electricity in the country. It's right here in the Phoenix area. That's where most of the Phoenix area electricity comes from. As a state as a whole, a little bit different. Most of it's natural gas. But just in the Phoenix area, this is actually where most of our electricity comes from, is from the nuclear power plants. These domes, that's where the nuclear material is. These three reactors is where the nuclear material is. So again, if EMCC is here, so again, it's about 30 miles southwest of us, kind of out near Wintersburg, Tonopah, so past Buckeye, so kind of way out here. You can take the 10. You can actually drive right by it. You can actually drive right by this thing. It's quite interesting. But they require a lot of water. All right, a lot of water. So this water is being lost. A lot of it's recycled, but water is being lost. So what's kind of cool is they actually take some of the water that the city of Phoenix, the city of Avondale, and Buckeye uses in the wastewater. So any wastewater gets cleaned by the cities. Some of that wastewater is actually pumped to Palo Verde for these pools to be used. So some of the wastewater that's treated goes here to help in this nuclear process. So it's pretty cool. They're kind of helping to recycle some of that water. Again, this is the layout of the area. So again, the reactors 1, 2, and 3. You have the cooling condensing towers over here, and then you also have, oh yes, right here, number 6. Here's where all that waste is stored. Here's where all the waste is stored. once the fuel is no longer useful, they put it in these large cement containers, and I'll show you those in a second. So what are some advantages and disadvantages? No air pollution comes from nuclear power plants. The only thing that's coming out of there is water. No air pollution. You're not burning anything. No air pollution. There's actually less radiation than a coal-burning power plant coming from nuclear power plants. If you were to stand next to a nuclear power plant or stand next to a coal power plant, you're actually getting more radiation from a coal-fired power plant than nuclear. It reduces the need on fossil fuels. Great. So it's what's considered a green energy. It's non-renewable, but it's a green energy. There's no pollution coming from these things. The only thing you need is water. However, disadvantage, major one, possibility of accidents. In the history of the world, there's only been a handful. Chernobyl, 3 Mile Island, Fukushima. We talked a little bit about that in tsunamis. But there is a possibility of accidents, which is very real. It's also difficult to dispose of waste. Currently, there's no place in the U.S. that accepts the waste, so any waste created by nuclear power plants that generate electricity, all the waste stays on campus somewhere. There's also concern about nuclear material being misused, or threat of terrorism that could you blow it up and cause an issue. And again, there's no long-term waste storage facility in the U.S. So with the radioactive waste that comes from the used fuel rods, this uranium, as it goes through the fission process, it turns to waste and degrades. And once it's below a certain level, it's not efficient to use for fuel in a nuclear power plant, so they got to put it somewhere, right? You can also create low-level radioactive waste from stuff that's on the inside of these reactors, clothing, tools, rags, pipelines, whatever, using the routine maintenance of these things. So all of this stuff is radioactive, and it's got to go somewhere, and oftentimes it's just left on site. When you're mining the uranium, the mine tailings could have small doses of uranium that just left out, that wasn't rich enough for it to be extracted, to the uranium to be extracted from the ore itself. It's just kind of left out. And in that case, sometimes that can contaminate surface water and groundwater. So, but in any case, all this stuff has got to be treated. So it can have an effect. All right. When it goes bad, it goes bad. But in the generating electricity portion, it's relatively green. This is the best photo I can come up with, but you can see the reactor in the background here, one of 3 at Palo Verde. So what they do is then take any, fuel rod that's used up or partially used up that's no longer efficient, and they put them in these steel-lined cement sarcophagi, and kind of just leave them on site, because there's no place in the U.S. that just accepts nuclear waste. We don't shoot it off into space because that would be a dumb idea. Imagine a rocket full of nuclear waste. It goes up and accidentally explodes. You're just going to rain nuclear waste all over an area. So that's not an option. So these to show you the size of these compared to a human, they take, again, these fuel rods, they put it in a sealed steel container inside of a cement container, and that's kind of where we contain the nuclear fuel, and it's usually done on site. So that's nuclear fuel. All right, that's nuclear fuel. Before we go, let me give another part of the super secret code. It is the number 3. The number 3. One more time, the number 3. So this is just one of alternative energy sources considered green, but it's not renewable. So what we'll talk about in the next videos are going to be green energy sources that are renewable: solar, wind, water. More on that in just a second. See you then.